Like, it would be like,
Now, most of you guys have worked through some of this before. This is not going to be anything groundbreaking, anything terribly scary about this. When we solve quadratic equations, one of the easy ways to do that is by using square roots. And as we get into this a little bit further, this is one of those methods that if you, eventually, I think Monday, we'll start doing what's called completing the square. It's one of the quick, easy ways to solve equations. But what I want to review with you guys is radical reviews of like how you simplify radicals. Now, I know last year you guys had that multi-view calculator.
that did it for us.
That did it for you. You don't have that now. And a lot of times I'm going to have parts of quizzes and tests that have non-calculator, which means you have to know how to, what these things mean. Yeah, I do a lot of non-calculator stuff.
Yeah, right.
Boo.
Is that 2 square root 6?
This one?
Yeah.
Yeah.
Yes!
So remember, what you're doing here when you're simplifying radicals is that you're looking for not prime numbers, we're looking for what are called perfect squares. So we're looking for, 4, 9, 16, 25, and so on. We're looking to see which one of the what is the largest perfect square you can get to simplify it out. Now, when you're talking about square roots, square root numbers can still be rewritten as composites, which means they can be rewritten as multiple square roots.
The laptop doesn't need to be open, guys. Thank you.
So when we're working with these, just like you could write 24, it can be written as 2 times 24, or 2 times 12, 4 times 6, 2 times 2 times 3 times 2. You can rewrite it in a bunch of different ways. When we do it this way, we're going to rewrite it in terms of perfect squares. So just like Emma said, it's the same thing as saying the square root of 4 times the square root of 6. Well, what's the square root of 4? 2. So it's 2 root 6. I know you guys have seen this one. It's not that crazy. Right. Well, there we go. Next one out, in this one here, we have a 9. So the 9 works would be 3 root 10. What's nice with straight multiplying, or bless you, just straight square roots, there is a shortcut that you can help yourself a little bit with on the calculator. Let me show you how that works real quick. It's not going to work really, it doesn't work as well with the division. You still have to rationalize denominators, but I'll show you if you get lost trying to remember what your perfect squares and stuff are, this kind of works. What I'm going to do is go to my y equals and clear out whatever I had in there. And we're going to do 24 and we're going to do 90. So let me show you how to do both of them. I want you to type in 24 divided by x squared. And now I want you to go right to your table. Your table probably starts at 0 or 1 or whatever.
Wait, 24 divided by
X squared, yes.
Like over x squared?
Yeah. Or you can just use the division symbol.
I did that and it said error.
Did you have everything cleared out of your y equals?
Wait. I got
So
it.
what you're looking for here is there's a nice shortcut that occurs. As you're going through your x and your y columns, you're looking for the last integer value in the y column before everything after it is all decimals. And in this case, it's a 6. 2 root 6.
Oh, fancy schmancy.
Okay?
Wait, how do you get that? But my x is at 4 and my y is at 6. Did I not like do this?
You have x cubed. You're welcome.
Fancy schmancy.
Works all the time. It's a nice little shortcut. It'll work when we take cube roots later on too. Oh, that's right. We have to work with cube roots. Doing the same thing. Look at 90. 90 divided by x squared. Table.
Oh, where's your answer?
3 root 10. It's a great shortcut to help you out. Okay? You guys ever see that before? What?
Do you like the fancy voices? Sure.
Alright. So the only thing that doesn't work with it then, unfortunately, will be when you have your division. I know. Dang it. So when you're doing division with radicals, what you're working on is you're taking the square root of the numerator, taking the square root of the denominator. So when you have the square root of 7/16, that's not too shabby. That's just the same thing as the square root of 7 or the square root of 16, otherwise known as root 7 over 4. And that's fine, you're done. You don't have to get rid of any other radicals within your denominator. Okay?
Oh,
Now, last year, one of the things you guys did spend a lot of time on, 30, 60, 90s, 45, 45, 90 triangles, where you had the root 3s and the root 2s when you had the denominators. You guys always rationalized the denominator, but your calculator did it for you. Here, you're going to still be doing the same basic principle, but you're going to be doing it by hand. Or remembering how to do it. It's ridiculously simple. So, if I look at 7 root 2.
or wait, you mean 7?
Oh, sorry.
7 over 2?
Thank you. That's what I meant. Yes. Wrong button. That one. Remember, all this means, we don't need 2 of these over there, sorry. All this means is this, is the square root of 7 over the square root of 2. And what we do here is we are going to multiply this fraction by some factor of 1 to change its shape a little bit. So what we do is we multiply it by what its same denominator. I multiply it by root 2 times root 2, but up here I also put a root 2. Because what's the square root of 2 divided by the square root of 2? 1. So in essence, am I changing anything by multiplying it by 1? No. So what's the square root of junk times the square root of junk? Junk. And what's 7 times 2? And you're done. That's it. Okay? That's it. The other part that we come across sometimes is when you have this. Let's say it's 3 over 1 minus the square root of 2. This will happen pretty often as well. Maybe not so much today, but as we get further along, we still do not want to have a radical in the denominator. So now what we do is we multiply by what's called a conjugate. You ever heard of that? It is, but math conjugate is the same basic, there's the same idea here, is what we can do here is we would multiply the denominator by the exact same thing, but we change the sign. By doing that, you are creating a difference of squares. Because whenever you have the same values, let's say x minus 2 times x plus 2, for example. If I have the same terms, opposite signs, when I FOIL that out, I get x squared minus 2x plus 2x minus 4. Doesn't the middle go away? So in this case, if I FOIL that out, wouldn't the radicals go away? That's what you're doing. You're getting rid of the radicals by multiplying by what's called a conjugate. We do this with square roots. We're going to do this in a little bit here with imaginary numbers as well. But if I multiply the bottom by 1 plus root 2, what has to go on the top? Because what is 1 plus root 2 divided by 1 plus root 2? Just 1. Okay. So what winds up doing here is you wind up FOILing out the bottom. First, here, I'll show you. Do you guys ever meet Billy Binomial? What now? Thank you. All right, here's Billy. Ready? First, outside, inside, last. Oops. It's Billy Binomial.
You just basically like drew the whole thing.
Yeah, he's grinning. It's like a Charlie Brown grin. It's Billy.
He's
got Elton John somewhere.
You don't have to make fun of Billy. He hasn't done anything to you. You're bullying Billy right now. Now, everybody okay why I wrote negative root 2 times positive root 2 as just 2? As negative 2, excuse me?
Yeah.
Square root of junk times square root of junk as always. So the middle terms go out, and then your denominator just becomes negative 1. The top becomes 3 times the quantity 1 plus root 2, which you just distribute.
3 plus.
And you can leave an answer like that, or you can distribute the negative up top. Probably not going to use a whole lot of this stuff right away today. This is just more of a what we're heading towards. Remember, all we're doing is multiplying by factors of 1. It's really all this winds up being. Okay? Yes, sir? Correct. Because I'm not multiplying. The 3 is not.
Oh wait, now I get it.
This is not inside the radical. It's outside. Okay? So what all this little practice like this stuff is going to allow us to be able to do is to solve a very basic equation like this. When I see something like this, the quickest, easiest route to solve is just to get x by itself.
Subtract 1 divided by 2
Okay.
equal x.
So 2x squared is 16. X squared is 8. Now, here's where you have to be careful. When you take a square root over an equal sign, what do you have to put? What? No.
Plus minus.
Plus minus. Oh no, we're all gonna drown!
Yeah, probably.
It'd be great if we had paper towels in the bathroom, so you might want to just go get a whole boatload of toilet paper. Yeah, because I don't have towels.
Allergic to water.
So whenever you take a square root over an equal sign, you always have to do plus minus. Always. And then you just have to remember, what is the square root of 8?
Wouldn't it be plus or minus 2 root 2?
Very good. And that's your answer. You bet. Solving equations by using square roots is ridiculously simple. There's not much going on here. Okay. It's just another method of doing it. Oh no, there's a fraction. I am so afraid. What do I do? No, knucklehead! Multiply by 3, get rid of it. Yeah, you never want to distribute a fraction into something, plus it has been raised by power. So you'd have to have that simplified out first before you can multiply it, because you got to take care of exponents first. Okay. So in a case like this, you're going to multiply both sides by 3, get rid of the fraction. Nope. Solve it by square roots. Take square root of both sides. Take the square root of both sides, then how do you move that 5? Subtract. Now, whenever we have a plus minus something on one side and we have to move an integer over, I want you guys to always get in the habit of putting that constant value or that integer first. That's my answer. It's negative 5 plus or minus root 21. I don't have to write it out twice.
Wait, it couldn't be plus or minus root 21 minus 5?
You can write it like that, but the only thing that I don't like when people do that is because they see this and they might write it as 16. See what I mean? People might simplify that as 16.
Yeah, but the root's only over the...
I know.
Okay. No,
It's more of a math etiquette that the integer comes first, then the plus minus, then the radical. Okay. The integer is just better. We're elitists today. Making this stuff up. Remember, the square root of 21 is just some decimal. I don't know what it is. It's more than 4, but less than 5. It's probably closer to 5. Because if you think about the square root of 21, where it falls into place, it falls between these two perfect squares. Which one of them is it closer to? So that means this is probably guesstimating 4.6-ish, maybe 4.7-ish. Estimation skills. Do you have those? You should work on those. Yeah. So that was 5-3. We okay?
No.
Let's talk about the good stuff. Let's talk about complex numbers. Let's talk about imaginary things. Let's talk about things that really aren't there but are there. Let's talk about spooky stories. What's that? Yes, like unicorns. We'll talk about unicorns. Okay, so how in the world do you take this? What does this mean? Square root of -1. It is, but let me rephrase that. When you take a square root of a number, you're looking for two exact same numbers that multiply together to equal the number underneath the radical.
That's not possible.
You're right, because to get a -1, you'd have to have a 1 and a,
-1.
last time I checked, 1 and -1 are not the same. Now, if it was just the square root of 4, we know it'd be 2 times 2 or -2 times -2. So mathematicians said, hey, this isn't hard enough. Let's make up this complex number and really mess with people. So what they developed was anytime you have the square root of a -1, it equals an imaginary number, I. Which basically allows you then to simplify radicals, whether they are positive or negative. So now your workload, you guys thought you only had to worry about half the numbers, positive numbers, take square roots. Your workload has now doubled. You're welcome. You seem so enthralled. Are you okay, Dietmar, or are you going to fall over? I'm worried about you there for a second. Okay. Glad you were right there. All right. Now, basically, this looks really weird, but it allows you to do this. If I take the square root of -12, I can rewrite the square root of -12 as a composite, just like we did before. But the first thing I do is I write it like this. It means the square root of -1 times the square root of 12. Well, what's the square root of -1? What's the square root of 12?
2 root 2. No, 2 root 3.
So
Thanks,
now,
sir.
when we simplify it out completely then, the way we write it is numbers first, and that's your answer. So in essence, anytime you have a negative, when you're taking the square root, you just take out an I. Go shoot your eye out, kid. Yes, sir.
When will you ever get a negative for
Oh, I'll show you in a second.
Wait, is there a number on your calculator that's I?
No.
So it's just like it's just not even a. It's just literally.
You think about it all the time. Just imagine it. It's great. I'm picturing an imaginary number right now, and it's beautiful.
Is it yellow?
It's not yellow. I think it's like blue, and it's sitting by the ocean, just chilling out in the sand.
I feel like you're picturing the eye.
I was by the ocean this summer. It was great. So that's what I'm imagining right now. Just wondered if it was comfortable and warm, and just sat there and swim in the water and threw my kids around. It's great. So I'm imagining fun things. It's good. Yay. So you ask, why do we have to be able to do this? Well, we can do this then. We can solve this equation. Why? Okay. Now, excuse when we're working with these imaginary numbers, it's basically, people always wonder, well, where do you actually use an imaginary number? Imaginary numbers are used more often when you're dealing with electronics, impedance, ohms. So if any of you guys get into electronic engineering, some of the physics stuff, that's where you'll see some of these things about resistance. It bounces off to an imaginary number. It's really the only real place that you see it. We can actually graph them. Graphing imaginary numbers is silly simple, but I'm not going to worry about that now. I got to save something for you guys to learn in pre-calc.
We're gonna save something.
I got to save something for you guys to do in pre-calc. So let's look at this. It's basically going to allow us to solve the quadratic equation like this. You walk through the process, you have 2x squared plus 3 equals negative 13. You walk backwards like you would normally, and it just allows you to get a solution. Before, when you guys saw a square root of a negative number, you'd say, uh-oh, no solution, can't do it. Well, your horizons have now been broadened. You can now thank me for making your lives more complex. Yes, ma'am. What's up?
Oh, never mind. I was gonna say, why can't you just like add the 2 below 7 0?
Then you have to move back the other way. So work your way backwards out of this. You're going to get 2x squared is negative 16. X squared is negative 8. Oh no, I'm afraid. I'm taking a square root over an equal sign. What do I have to do? Got to do that the other time.
Plus or minus?
Plus minus. So x equals plus or minus what?
Root
2I root 2. You're done. You can still simplify a radical if you have to take the square root of 8. You don't remember that it's 2 root 2. Remember that little trick I showed you with the calculator by taking 8 divided by x squared? And just look through the columns, you'll find it. And just don't forget to put an I in it. It's really not that difficult, is it? It's just weird. So you can imagine your homework. No, you're going to have to actually physically do it. I know. I know.
I can imagine. It doesn't exist.
But it doesn't exist.
What is it? The limit does not exist. Isn't that from Mean Girls or something? Is that right? How do I know that? Because everybody says it when you're in calculus. We talk about limits. The limit doesn't exist. What? It's a movie about math. It's not that bad.
Yes.
It's like 2 seconds about math.
But it's not that bad, the math part. And the rest of it's just weird. It's old too. Wasn't it like 02, 03, something like that? Yeah. Was it 02, 03, somewhere in there? Google that for me, would you?
What are you talking about?
Mean Girls. I think it was
Mean Girls?
0.
I think it was
I don't think it's any later than 05. It's gotta be. 10
Wait, when
years
was
old.
it like released?
Really?
That's what I said.
Are you comfy though, Philbaum?
Yeah.
Thanks. You're the best.
Yeah.
You're like that. Thank you. So, what do you do first?
Subtract 147.
You subtract 147. Now what do you do?
Cry.
You do, no, there's no crying in math.
Yeah, I'm on no crying in that.
I will say, the Big Poppy commercial, there is no crying in baseball, and then he's like, my eyes are just sweating. That's a great line. Hey, do you guys know how to shortcut divide?
49.
Gosh, Emma, nice job.
3 goes into 14 how many times?
Twice. No, 4.
How many are left over? 3 goes into 27 how many times?
9.
What's the square root of negative 49?
Plus or minus 7.
7.
I 7?
7i. 7i. And then you just move the 5.
Plus or minus 7i minus 5.
always put the integer value first before the i's. It's just the more proper way of writing it. Okay? And that's it. We'll worry about conjugates of i's and all that tomorrow, and adding, subtracting, multiplying, and all that kind of junk. It can get kind of messy if we're not careful. So this looks weird, but there's two sections. Hey, I'm going to start abbreviating this. What do you think that stands for?
Out of bounds.
Wait, what did you do? Oh.
Out of range. So an old book, I already have them tabbed. Like I said, they're tabbed out for you. I just have to put the problem numbers on there. So it's 22 through 50 every other even, which means by fours. And then solving the equation parts on there is the 51 through 67. I'm giving you the odds so you can check your work. Same thing with the imaginary ones. Odds so you can check your work. So you should fly right through this. I'm trying to think that 71 is the one I don't want to do that. For some reason I think it is. Let's check that real quick. Yeah, we'll stop at 67. Because I'm gonna wait on 71 until we go back. Then we'll circle back and do the word problems. The word problems with these things, it's all calculator. I'm not gonna worry about that until we get all the other stuff done first, and then we'll go back to the calculator with that. Is that fair enough?
Travis says no.
Good times, right? Your math universe is just doubled because now you have imaginary numbers. Don't you feel good about yourselves? I do. I feel good about myself. What's that? True, but now I feel better that I've told you about it. So my life has become more rewarding in such a way that your lives have become more rewarding.
Mr. Murphy, can I come with you?
Yeah, just go sign them out in the back there by my little Chromebook there. All I ever wanted to do when I was watching that movie is go get fries. That's all I wanted the entire time watching that movie.
Wait, is that McDonald's?
Yeah.
Yeah, but we have to fill out questions, so it's just.
Wait, but okay,